Good day all, and you're all welcome to today's class. Last time we we talked about study section 4 unit 1, and today which is random variable. Today our discussion is based on study section 4 unit 2, which is a distribution function. Objectives. What are the objectives of this study unit? The objective of this study unit is to provide students with a clear understanding of the random variables and their roles in probability and statistics. By the end of this study unit, students will be able to understand the meaning and role of distribution function in describing continuous random variable, learn how to construct and interpret cumulative distribution function, which is the CDF, from probability density function and vice versa. Develop the ability to calculate probabilities using distribution function for continuous variable. Define and apply the concept of mathematical expectation to determine the average, and use mathematical expectation to compute the moment variance and other statistical measure or expected value of a random variable. Learning outcome. By the end of this unit, students will be able to 1. Define a distribution function and explain its roles in probability theory. 2. Differentiate between a probability density function and a cumulative distribution function for continuous random variable. Use the CDF to calculate probabilities over specific intervals for continuous random variable from a given PDF and vice versa. Define mathematical expectation and explain its significance in describing the long-term average outcome of a random variable. Compute the expected value or the mean of a continuous random variable using integration, and apply mathematical expectation to calculate variance, standard deviation, and other statistical measures. Introduction. In probability and statistics, a distribution function describes how the values of a random variables are spread over its possible range. Before when we were talking about random variable, I think I said there are two types of random variable. We have the discrete random variable and the continuous random variable. So for a continuous random variable, this is typically represented by two related functions. The first one is probability density function, which is PDF. What is the usefulness of probability density function? Probability density function shows how probability is distributed over a values, but does not directly give probabilities for a single point. Because I told us that we use probability mass function for discrete, while we use probability density function for continuous. So probability density function works with range or interval. It shows how probability is distributed over values that are within a range or interval, but does not directly give probability for a single point since it is uncountable. So another one is the cumulative distribution function, which is the CDF. It gives the probability that a random variable takes on a value that is less than or equals to a given number, making it a powerful tool for calculating probabilities over intervals. Another important concept in this unit is mathematical expectation, which I said it is either E of X. We can also call it expected mean or mean, mu. So this represents the mean or average value of a random variable over a long run and is a fundamental measure in probability. Expectation can also be extended to compute higher order moments, such as from the previous class, random variable. We can see that when we are estimating, we estimate our expected mean, we estimate the variance. So we can also use it to calculate higher order moments, such as variance, which measures variability in the data. That is, variance that measures the spread in the data. Distribution function. What is a distribution function? A distribution function, which is also called cumulative distribution function, CDF, for a random variable x, is a function f of x, capital F of x, that gives the probability that our capital X takes on a value that is less than or equals to small x. f of capital X gives the probability that our capital X takes on a value that is less than or equals to X. So our f of X equals to P, probability of capital X is less than or equals to small x. Then under distribution function, we have distribution function of a discrete random variable. The CDF, cumulative distribution function of a discrete random variable, is step-shaped. The cumulative density distribution function of a discrete random variable is step-shaped. That is, jumps at each possible values of x. When we are a step-shaped jumps at each possible values of x, and it is computed by adding up the probability from the probability mass function, because I told us that the probability mass function, we use it in discrete random variable. So by adding all the probability mass function up to the given value, so our probability density cumulative distribution function is the CDF, while probability PDF is probability mass function. So the CDF of a discrete random variable is step-shaped, jumps at possible value of x, and it is computed by adding up the probability from the probability mass function, which we use for discrete random variable, up to the given values. That is, f of x equals to p of x less than or equals to x. That is summation of t less than or equals to x, p of x equals t. What are the properties of the CDF for a discrete random variable? What are the properties of the cumulative distribution function for a discrete random variable? 1. Discrete, range between 0 and 1. For all x, 0 is less than or equals to f of x, which is less than or equals to 1. That is the first property. Second property, non-decreasing function. The CDF of a discrete random variable is a non-decreasing function. If a is less than b, then f of a will be less than or equals to f of b. This means as x increases, f of x never go down. It either stays the same or jump upward. Let me repeat myself again. Non-decreasing function. If a is less than or equals to b, then f of a is less than or equals to f of b. This means that as x increases, f of x never goes down. It either stays the same or jumps upward. The third property is of the CDF increase in jumps at the possible values of x. So each jump size equals to the probability at that point. Jump at xi is equals to probability of x equals to xi. Another property is right continuity. This CDF is right continuous in a discrete CDF function. It is right continuous, meaning the lim of h plus f of x plus h equals to f of x. That is, there is no gap when approaching from the right. Another one is limit at extremes. As x goes to negative infinity, lim n ranges from n to minus infinity, f of x is 0. Also, as x goes to positive infinity, lim n approaches negative infinity, f of x equals to 1. Then probability from CDF, cumulative distribution function. For any two number, a less than b, probability of a is less than x is less than or equals to b, which is equals to f of b minus f of a. For discrete variable, we can also find p of x equals to x, which is equals to f of x minus f of x inverse negative. Example, check the following function given by f of x is x plus 2 over 25. For our x ranges from 0, 1, 2, 3, 4, and 5 is a probability distribution function. So from here now, they said our x is 0, 1, 2, 3, 4, 5. To estimate f0 will be x plus 0, 0, since our x is from 0. For f0, when our f of x is 0, that will be 0 plus 2 over 25. When our for f1, that will be 1 plus 2 over 25, which is 3 over 25. For our f2, that will be 2 plus 2 over 25, which is 4 over 25. Then to estimate our f3, that will be 3 plus 2 over 25, which is 5 over 25, which is 1 over 5. To estimate our f4 will be what? 4 plus 2 over 25, which is 6 over 25. Then our f5 will be 5 plus 2 over 25, which is 7 over 25. Then sum of fx, summation of all our xi, which is summation of fx1 plus fx2 plus fx3 plus fx4 plus fx5 will be 2 over 25 plus 3 over 25 plus 4 over 25 plus 5 over 25 plus 6 over 25 plus 7 over 25. When you add all these together, it will give you 27 over 25, which is equal to 1.0808. Therefore, f of x is not a probability distribution function, since it is not giving us value of 1, because we said it was ranges from 0 is less than or equals to x is less than or equals to 1. So since it is greater than 1, the f of x is not a probability distribution function. Another example, if our x equals to number of beds in 2 coin tosses, p of 0 is 0.25, p of 1 is 0.5, p of 2 is 0.25. Then f0 is 0.25, f1 will now be 0.25 plus 0.5, which will give us 0.75. f2 will now be 0.25 plus 0.75 plus 0.25, which will give us 1.0. Therefore, our f of x is a probability distribution function. Distribution for a continuous random variable. That is, we've talked about discrete. Now, a continuous random variable is described by a probability density function. Probability density function, PDF. For this one is probability density function, PDF. The CDF is obtained by integrating the PDF. To obtain the CDF of a continuous random variable, we will have to integrate the probability density function. When we integrate the probability density function of a continuous random variable, it will give us the CDF, cumulative distribution function. So if our f of x, which is our CDF, is equal to minus infinity to infinity f of t dt, that is our CDF. Since p of x equals to 0 for a continuous variable, probability are found over intervals, because as anything that has to do with continuous must be within a range or intervals. A is less than or equals to b, probability of a is less than or equals to x is less than or equals to b, which is fb minus fa. What are the properties of a PDF for a continuous random variable? 1. Ranges between 0 and 1. For all real x, 0 is less than or equals to f of x is less than or equals to 1. The CDF always starts at 0 and approaches 1. For a continuous random variable, the CDF always starts at 0 and approaches 1. Number 2, non-decreasing function. If a is less than b, then f of a is less than or equals to f of b. This means as x increases, f of x never decreases. Also, for a continuous random variables, f of x is smooth with no jump. If you remember, we discussed about jump in a discrete, but here in continuous is a smooth. F of x is smooth with no jump, because p of x is equals to x is equals to 0. This means the limb n approaches 0, f of x plus h is equals to f of x. Also, the derivatives of the CDF is the PDF. F of x CDF equals to derivative of the PDF. Conversely, f of x is integral minus infinity to infinity f of t dt. Limit at extremes, that's another property. As x approaches negative infinity, lim n approaches negative infinity, f of x equals to 0. Also, as x approaches positive infinity, the limit of n approaches positive infinity, f of x equals to 1. Now, let's go to the example. Check the following function given by f of x is k exponential raised by minus 3x, s is greater than or 0, 0 elsewhere. For x greater than 0, find the value of k and p of 0.5 less than or equals to x. Solution. Now, if we integrate this, integral is from 0 to infinity, k exponential raised by minus 3x ds equals to 1. If we integrate this, it will give us minus k over 3 e exponential raised by minus 3x from 0 to infinity equals to 1, because we said the PDF of a continuous random variable is 1. So if we integrate this, it will be 0 minus k over 3 of 1, which is k over 3 equals to 1. K is equals to 3. If you cross multiply, your k will be equals to 3. Then second question, if our ranges or interval is from 0.5 to 1, 3e raised by minus 3x ds will be minus e. If we integrate this, it will give us minus exponential raised by minus 3x 1 to 0.5, which is 0.1733. Then mathematical expectation. The expected value of a discrete random variable having distribution function p of x is given as e of x. I think I've mentioned that earlier, which is summation high ranges from 1 to n x p of x. And for the continuous, I said anything that has to do with continuous, make use of integral. So for continuous random variable, we have e of x equals to minus infinity to infinity x f of x dx. Here for discrete is summation xp of x, and for continuous is integral x f of x. Now, if x is a discrete random variable with PDF, p of x and g of x, and if p of x is any real value function, the expectation e of g of x is equals to summation x ranges from 1 to k, g of x, p of x. That is for a discrete random variable. Please take note, when we want to estimate or want to calculate the expectation for a discrete random variable, we use this. We use summation g of x, p of x. Then for a continuous random variable, e g of x equals to minus infinity to infinity g of x, p of x dx. For a continuous random variable, when we want to calculate the expectation of a distribution function. The variance of the random variable of x is given by variance e of x minus e of x whole square, like the one we used to estimate the variance. And the standard deviation is given as simple of x equals to root of x minus mu x. So for any random variable x, 1, e of x ax plus b equals to e of x plus b. Please try and prove these two, 1 and 2, and see how we arrive at this. This one is a proving. Please try and work on it. Example, using the above result, compute the variance of x as given in table below. If our x are 0, 1 and 2, and our p of x are 0.1, 0.5 and 0.4 respectively. So we should calculate our e of x for a discrete random variable. I've once said e of x is summation x p of x. What is our x? Take your x, use it to multiply your p of x, which equals to 0, plus take your x, use it to multiply your p of x, that is 1 times 0.5. Then take your x, use it to multiply your p of x, then add everything together. That will give you 1.3. Then we look for variance. To estimate the variance, to calculate the variance, we first do for E of x squared, that is x squared times p of x. That is xi squared times p of xi. That means x1 square times p of x1, x2 square times p of x2, x3 square times p of x3. So then we can, from there, after getting our E of x squared, then we can estimate our variance. So our variance is E of x squared minus E of x all squared. So here now we estimate our E of x squared, which is x squared p of x, and it gives us 2.1. Then we calculate our variance by taking away E of x squared minus E of x all squared, which gives us 0.41. Thanks for listening.